Hi everyone. Today I'm going to share something about the problem solving in mathematics, actually in mechanics paper 4 in Cambridge International Examination. This is for Cambridge International Advanced Subsidiary and Advanced level. This is the paper for mechanics 1 or M1. This is for October or November 2017. We have only 1 hour 15 minutes to solve this problem. Okay, let's start. Do I want to explain about how to solve these problems. Now, this is about the number 1. The particle mass 0.2 kilogram resting in equilibrium and roll plane inclined 20 degrees to the horizontal. Question 1 is so that the frictional force acting the particle is 0.684 Newton. Correct and significant feature. Okay, let's draw the diagram of the particle when the object on the road on the inclined plane with the inclined angle is 20 degree. So we have which and also we split into mg cos theta and mg sin theta in for example this is the x axis and this is the y axis. So in the x axis we have frictional force also and mg sin theta. So solved by the total force equal to 0 in equilibrium. Total force equal to 0. This is the on the x direction. F frictional force minus mg sin 20 degree equals to 0. So that's mean frictional force equals to mg sin theta, or we substitute the number. M is 0.2 and gravitational is 10. So sine 20, and then we get F frictional force equals to 0.684 Newton. Then continue to the next number, to the next question, still in number 1. The coefficient friction between particle and plane is 0.6. A force of magnitude 0.9 Newton is applied the particle down line of the greatest slope in the plane. The particle accelerates down the plane. Question 2. Find this acceleration. Still using by the Newton's second law. Newton's second law, there is total force equals to ma in the x direction, because in the x direction the object is going down by the force 0.9 Newton. Also we have on the x direction we have still mg sin and frictional force. And then in y direction total force equal to 0, because on the y direction there is no move on the object. So we calculate from total force in x equals to ma. We find this is F minus frictional force plus mg sin theta equals to ma. Then frictional force equals to mu normal contact, which the normal contact is by using the total force in y equal to 0, because normal contact is on the y direction. Yeah, normal contact force minus mg cos theta equal to 0, so we can get the normal contact force equals to mg cos theta. Then m equal to 0.2 times 10 times cos 20, and then we get 1.879 Newton of the normal contact force. So after that we substitute this number into here. 0.9 minus 0.6 times 1.79 plus 0.2 times 10 times 20 equals to 0.2a. And then we get 0.9 minus blah 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 plus blah 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 equals to 0.2a, and then 0 point something equal to 0.2a, and then we get a equals to 0.2283 in meter seconds minus 2. Okay, that's the number 1. So continue to number 2. In this number 2, a block of mass 15 kg hangs in the equilibrium below a horizontal ceiling attached on the string as the shown in the diagram. One string inclined 45 degrees to horizontal, and the tension is this string 120 Newton. Here, the other string inclined at theta to the horizontal and tension T Newton. When the value of T and theta, tension and the angle here. So we need draw the diagram first in the x direction and also in the y direction. For the first, we have tension drop in here, and then we have 120 Newton in here, and also we have W weight equals to mg. M is 15, g is 10. We get 150 Newton. So after splitting into x and y direction, we get the, for the t, we have t cos theta here, and then t sin theta here. And then for the 120 Newton, we get the 120 cos 45, 120 sin 45, splitting from the 120 Newton here. So we can use, after that we use the formula for the in equilibrium total force equal 0 in the x. In the x, we have t cos theta minus 120 cos 45 equal to 0. So we can t cos theta equals to 120 cos 45, or t cos theta equals to 84.85. This is the equation 1 from the x direction. So we continue for the y direction. On the y direction, we still use total force in y direction equal to 0, because this is the system in equilibrium. T sin theta equals to 120 plus 120 sin 45 minus weight equal this weight is 150 equal to 0. Then we get T sin theta equal to 150 minus 120 sin 45, and we get T sin theta equals to 65.15. This is the equation of 2. Okay, we need to combine between equation 1 and equation 2, and then after that we need to substitute, we need to eliminate to find the T and theta. We have T cos theta equals to 84 over 84.85 by the equation 1, and then we get we have T sin theta equals to 65.15 from the equation 2. Then after that we eliminate by dividing them, and then we get tan theta equals 0.76, and we get theta equals to 37 degree. Okay, after we get the theta equal 37 degree, we can use this angle into come here or come to here to find the t. For example, we use t cos theta equals to 84.85, t cos 37 equal to 84.85, and then we get t equals to 84.85 over cos 37 degree. This is equal to 106.59 Newton. Okay, this is the tension drop, and this is the theta on the question 2. Okay, let's continue to the next number 3. In this number, we read first. A car travels along a straight road. The constant acceleration is present stroke point A, B, and C. The car passes point A with velocity 14 meters second minus 1. The two sections AB and BC are the equal length. The time taken to travel AB and BC are 5 seconds and 3 respectively. Okay, question 1. Write down the expression for the distance AB in terms of the acceleration of the car. Write down similar expression for the distance AC, and so the acceleration of the car is 4 meters seconds minus 2. Okay, let's draw the uh, movement of the car from point A to B and then come to C. Start from A, the car have velocity 14 meters second minus 1, and then travel time from A to B is 5. B and C travel time is 3 seconds. Okay, we continue for the expression of the AB, distance AB. Distance AB equals to velocity, initial velocity times t plus a half acceleration times TEB square. We get 14 times 5 plus a half A plus 5 square, and then we get 7t plus 12.5a. This is the expression of SAB, distance AB. So continue to SAC. In this section SAC, we have VA TAC plus a half A TAC square. 14 times 8 plus a half A 8 square. We get 112 plus 32A. Okay, this is the expression of SAAC, distance between A to C. So continue to here because AB is equal length. So we decide AC equals to 2AB. So SAC equals to 2 times SAB. So this is the expression 70 plus 32A equals 2 times of expression of SAC. 70 plus 12.5a. So we get the A equals to 2 times 70 equals to 140 minus 112 come from here, and then over 32 minus 25. 25 is come from 12.5 times 2, and then we get 28 over 7. This is equals to 4 meters seconds minus 2. This is the acceleration come from the relation between SAB and SAG. Okay, continue to next number. The next number is find the speed of the car as the passes point C. So we only use the VC equals to VO plus 8 times TAC. This is initial velocity 14. This is A acceleration we get before. And TAC equals to 5 plus 3 because TAB, TBC equal 5 plus 3, and that become 8 seconds. 14 plus 32 equals to 46 meters seconds minus 1. This is the velocity on point C. Okay, that's the number of 3. Now number 4. In this number 4, a particle P projected vertically upward from horizontal ground with speed 12 meters second minus 1. Question 1. Find the time taken P to return the ground. Okay. Use the formula when the particle on the highest point, the velocity is come to 0, and the highest point, this is Vt equal to 0. We only use Vt equals to Vo minus Gt, minus because the particle is going up. This is decelerated by gravitational acceleration. Okay, Vt equals to 0, and then Vo equals to 12. Minus G, we use G is in 10, yeah, and then we get T equals to 1.2 seconds. But the question is the time until the ground. The T until the ground is 2 times of T until the highest point, and then we get T equals to 2.4 seconds. Now, the time in second after P projected is denoted by T when T equals 1. A second particle Q is projected vertically upward with speed 10 meters seconds minus 1. from a point which 5 meters above the ground. Particle P and Q move in the different vertical lines. Okay. Question 2. Find the set value of T, with the particle moving in the same direction. Okay, in the same direction is going up and going down. So we calculate for the particle P. We have until the hash point before t equals to 1.2, and then when t equals 1, this is start that the particle q start going up with the velocity 10. Okay, then if we find the in the hash point what the time and then what is height, we get a 0 in the maximum velocity, maximum height, the velocity is 0, vo equals to 10, and minus gt 10 times t, and then we get t equals to 1 second. So the particle key until the hash point, they need only 1 second. So what the height is? What the height is POT minus a half GT squared, and then we get 10 times 1 minus a half 10 times 1 squared, and then we get 10 minus 5 equal to 5 meter. So the height into hash point, the distance into hash point equal to 5. The point start, the particle key start, the velocity 10 is 5. So the total height is equal to 5 plus 5. This is equals to 10. Okay. Now, what the hash point of the particle P, we have to calculate for h. H is VOT minus a half GT squared, and then we get 12 times 1.2 minus a half 10 minus 1.2 squared, and then we get something, and then we get 7.2. Okay, now we decided moving in the same direction when they going up is start from 1 second until 1.2 second, because the particle Q need 1 second, but the particle P need 0.2. Then when they come into going up, there is only start from T1 until 1.2. Then after 1.2, the particle P is going down. Okay, what the going down? The going down is when the 1.2 and T until 2, because until 2 second, the particle Q already on the ground. So this is the answer question. When the going up is T between 1 until 1.2, and the when going down, when going up is what T from 1 until 1.2, and the when going down is 1.2 until 2 seconds. Okay, let us continue to the next number. The next number is a cyclist riding up the strike hill inclined at an angle of the horizontal where sin alpha is 0.04. The total mass of the bicycle ride is 80 kg. The cyclist is riding the constant speed of 4 meters seconds minus 1. There is a force resisting the motion. The work done by a cyclist against the resistant force over distance of 25 meters is 600 joules. Okay. Question 1 is find the power output of the cyclist. We go back into the definition of work done. The work done equals to force times distance. F is driving force by the cyclist. And then we have the formula of the Newton first law. When the object is in constant velocity, the total force equal to 0, right? Then we'll continue. Start from here. Work done is equals to 600 equals to force, driving force. This is driving force is driving force by resistant force. This is the against the resistant force. So this is driving force 2 against the resistant force. Times 25. 25 is distance. Distance when the work done equals to 600. So we get the force driving force equals to 600 over 25. This is 24 Newton. This is the force for the against the resistance force. So we will use this into here. Total force equal to 0 because in the constant speed, driving force minus resistance force minus mg sin theta equals to 0. Driving force equals to here plus here, yeah, because move in the different side, negative become positive, negative become positive. F resistance force plus mg sin theta. Resistance force equal to here because this is the, as I said before, this is against resistance force. 24 plus 80 times 10 times 0.04. This is sin theta, sin alpha. We get 56 Newton. Then the power, use the power equals to F V, F times V, F equals to 56, yeah, times 4, this just become 124 watt. This is the power output of the cyclist. Now, continue to the next number, to the next question. The cyclist reached the top hill, where the road became horizontal with speed 4 meters seconds minus 1. The cyclist continued to walk at the same rate on the horizontal of the road. Find the speed of the cyclist 10 seconds after reaching the top of the hill given the work done of the cyclist during the work against the resistance force is 1200 joules. Okay, this is the diagram of the cyclist after he living on the inclined road, yeah, and then after that the horizontal road. The velocity of the peak of the inclined road equals to 4 meters second. After t 10 seconds, we need to find the velocity, final velocity after 10 seconds. Okay, let's start from the work done equals to v FV, yeah, work done is 1200 joules equals to driving force time, and then we get driving force equals to 1200 over 4 equals to 300 Newton. Now, use the formula, use the Newton's second law. There's force equals to ma, yeah, or a equals to change of velocity over time. Yeah. Then we have f equals to 300, m equals to 80, vt we need to find it, and then vo is 40 is 10. Blah blah blah. 10 at 300 over 8 equals vt minus 4, and then 37.5 equal to vt minus 4, and then we get vt equals to 41.5 meter second minus 1. This is the velocity after 10 seconds. The cyclist, after the cyclist in the horizontal plane, yeah, after 10 seconds. Okay, now question, the next question is question 6. Okay, question 6 is, yeah, two particles P and Q is the mass, each of mass m kilogram, are attached in the end of the inextensible string. The string was over fixed smooth poly with attached the edge of road plane. The plane is inclined on the angle alpha to the horizontal, where tangent alpha is 7 over 24. Particle P rests on the plane. The particle Q hangs vertically as on the diagram. The string between P and poly is parallel to a line of the greatest slope of the plane. The system is in limiting equilibrium. Question 1 is, so that the coefficient of friction between P and the plane is 4 over 3. Okay. Now let's see about the diagram move of the particle P and Q. The particle P on the slope plane where the angle is alpha. So we have the force on the P, this is frictional force, This is mg sin theta. This is splitting from mg, and then we have mg for the particle q. So in the equilibrium, total force equal to 0. Newton's first law. Mg plus mg, because this and this one direction, this is plus. But frictional force in the different direction, opposite direction, we get the negative for frictional force. Then become equal to 0. Also, all frictional force equals to mg plus mg sin theta. Then frictional force equals to mu normal contact force. This is the normal contact force here. Normal contact force is mg cos theta, or the force opposite with the normal contact force, equals to mg plus mg sin theta. We can cancel mg, and mg, so we get mu cos theta. Mu cos theta equals to 1 plus m sin theta. 1 plus sin theta. Or we decide mu equals to 1 plus sin theta over cos. Yeah. For the tangent theta, 7 over 24, we get the sine and cos theta into the number. For the sine theta, we get the 0.28, and then for the cos theta, we get 0.96. So after we calculate this, we get 1.33. 1.33, this is equal with 4 over 3. Okay, we did this is already proof, yeah, because the answer is same the after we calculate 4.3. Now the next question still on the number 6. A force of magnitude 10 Newton applied to P acting on the line greatest slope of the plane, and P accelerated at 2.5 meter second minus 2. Question 2 is find the value of m. Find the value of mass of the particle P and Q. Thus the particle m and P, the mass is same. Yeah. So this is the diagram for the two particle P and Q. On the P we have force here, 10 Newton, yeah, applied on the particle P, 10 Newton. And then we have mg sin, and then we have frictional force. The frictional force is opposite y direction because after F acting on the particle P, the movement into going up with the slope theta. Then we have still mg on the particle Q. So we just calculate for this question about the Newton's second law. Yeah, that's total force equals to ma. The force is F, yeah, minus frictional force because this is the opposite direction, minus mg sin theta. Also this is still on the opposite direction, minus mg. Also this is the opposite direction with the F, so equals to ma. F minus this is the normal contact force times u is frictional coefficient, mg sin theta minus mg equals to ma. Then after that we substitute the number of each variable. Yeah. Mu equals to 4.4 over 3, mass 10, 0.96, this is cos theta, m, g is 10, sin theta equal to 0.28, and mg, g is 10, and then a equals 2.5 as the question above. So we get the 10 minus 12.80 m minus something m minus 10 m equals to 2.5 m. And then we get 10 equals to 3.1 m, and we have m equals 0.40 kilogram. 0.40 kilogram, or we can change into the different unit here. Change in unit gram. This is 10 with 1000 equals to 430 grams. Okay, that's the number 7. Continue the latest number. Continue the next number. This is the last number, number 7. The number 7, a particle start from rest, move the straight line, the velocity particle at t second after the start if v meter second minus 1, where v equals to minus 0.01 to the power 3 and 0.23 square and minus 0.4 t. Okay, now the question 1 is find the two positive value of t for which the particle instantaneously at rest. At rest, it means the velocity come to 0. Then we get v v1 to v into 0, and then we get minus blah 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 minus something something and the something. That is we multiplying with 100. This is the equation become here. This one, and then we get the factorial of the t, t minus 2 and t minus 20 equal to 0, so we get t equals to second, also t equals to 20 second. This is the two positive value of t which the particle instantaneously at rest into second and in 20 second. Okay, continue to the next question. Question 2. Find the time which the acceleration of the particle is greatest. Yeah. Acceleration is a, this is derivative of velocity by over time, that we get a after we derivative 0.03 t square plus 0.44 t minus 0.4. Time at the acceleration of the particle is greatest when the derivative of this equation it come to 0. So if we derivative of this equation, this becomes 0.060 plus 0.44. This is become to 0. So we get t equals to 0.44 divided by 0.06, and then we get 7.33 seconds. This is the time which the acceleration of the particle is greatest. At greatest when the derivative or difference by a equal to 0, we get t in greatest the acceleration. So the last question is for the number 7 is find the distance traveled by particle when its velocity is positive. The distance is we use the integration of the equation for the equation for the this velocity. So we get after we integration this this equation, we get 0.01 and something and something and something. This is the integration by this equation. So this is the number of t or h of t, and then we need to substitute 20 and 2 become to replace t and t. After replace the 20 and 2 become here, and this is 2. After that we calculated, we use the calculator, then this is minus 1600 over 4 plus something minus 80 minus something and minus something 0.8, and then this is around 106.67 minus this is around 0.92, and then we get 105.75 meter. Okay, this is the distance when the particle traveled the velocity is positive. Okay, thank you very much for watching my video. Don't forget to like, comment, and subscribe. See you on the next video. Thank you very much.